Hello learners, my name is Teacher Cyrus. This is a mathematics learning video and I will be taking you through the strand known as numbers, which is the first strand in grade 9. Our substrand is indices and logarithms. This is a grade 9 strand and I am going to show you the formulas that you need to apply in this substrand, and as well as I will be solving examples for you, and then I will give you an exercise to try out whether you have understood what we have covered or not. I hope you are going to enjoy this lesson, so I welcome you to other strands that I have prepared before. So welcome to this lesson. In this lesson, we are going to cover the following areas. Number one, we are going to look at how to express numbers in index form. Therefore, we will see how to express numbers in index form. That is the first area that we are going to cover in this lesson. Then number two, we will look at the laws of indices. So we normally have the three laws of indices. We are going to discuss them in detail. So I welcome you as we try to simplify this area. When we talk of indices, I want us to look at this scenario. If you are been given, or you are given 3 power 5, if you are given 3 power 5, then somebody may ask you, what do we mean by this statement? So 3 power 5 means it is 3 multiplied by itself 5 times. So you multiply 3 by itself 5 times. So it will be 3 multiplied by 3 multiplied by 3 multiplied by 3. 5 times this 1 2 3 4, so times 3. So this is 1 2 3 4 5. So we have multiplied 3 by itself 5 times. So this is what we mean 3 raised to power 5. So if you are given 2 power 4, so this means it is 2 times 2 times 2 times 2 4 times. So 1 2 3 4. So if you are been given a number raised to a certain number, then it means that that number which is below there, we multiply that number the number of times the power dictates. So we we refer 5 and 4 as a power. So 5 and 4 is referred as a power. It's referred as a power. But since we have said 5 and 4 is a power, then we can read the two statements as 3 power 5, or we can say the second one is 2 power 4. So the number above here is what we refer as a power. So the number above there is referred to as a power. But there is one thing that I want to remind you. Power is the same as, or a power is the same as index. Power is the same as index. Since power is the same as index, then 5, which we referred as power, is we can refer it as index. So 5 can be referred to as index. So also we can say 4 is also an index. So the two are indices. in simple terms, we are saying that 5 and 4 are indices. What do we mean by indices? So indices is the plural. Indices is the plural of index. So indices is the plural of index. So index is just one power. When these powers are many or there are more than 2, then we call them indices, or they are referred to as indices. I want us to look at this example. I want us to look at this example. If you are given 3 power 4, 3 power 4, then we can have 4 power 6, can have 4 power 2, and we can have 5 power 4. So here we have what we refer as indices. So 4, 6, 2, and 4 are referred to as indices. So this is our index, this is another index, this is another index, this is another index. And we have said when these powers are more than 2, then we refer them as indices. So 4, 6, 2, and 4 are our indices. But we have numbers like 3, 4, then we have 5, which are below the indices. So these numbers are referred to as bases. We refer them as bases. So the number below there is a base, and the number above is our index. So we can have this statement and say, if you have 3 power 5, then 3 is our base and 5 is our index. So 3 is our base, so this is our base, and this is also our index. So those are the two statements that I want you to have at your fingertips. So if you are told to identify a base, you can easily identify. If you are told to identify an index, then you can also identify it without any difficulties. But I've said this, indices is the plural of index, which is the same as the power. So I've said indices is the plural of index, which is the same as the power. So I want to repeat again, indices is the plural, it is the plural of indices is the plural of index, which is the same as power. Indices is the plural of index, which is the same as power. So that is all about indices. So we want to look at, remember, before we move to something else, I've said if you are given numbers and you are told to write the number in, or you express the number in index form, so you must have a base and also you have the power. For example, if you have 25, you can be given 25 and you are told to express this number in index form. So this number is the same as 5 power 2, or 5 index 2. So 5 index 2 is the same as 5 times 5, which is the same as 25. So you just express this, becomes our base, and also 2 is our index. So that's all about indices and expressing numbers in index form. And I want us so I want us to move to something else, laws of indices. Laws of indices. Now let us consider this case. So let us consider this. If you are given, for instance, if you are given a number like a power 3 multiplied by a power 2. So how do you solve that, or how do you solve this? So when talk of a power 3 is the same as a multiplied by a multiplied by a 3 times. A power 2, so also you also multiply by a multiplied by a. So how many a's do we have in this case? We have 1, 2, 3, 4, 5. So our answer will be a power 5. The second scenario, if you are given a power 6 divide by a power 3, a power 6 divided by a power 3, how do you solve such a question? So when talk of division, there are two ways we can do this. So division, we have a, the first one is a multiplied by 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 a. So how many are they? 1, 2, 3, 4, 5, 6. We divide by a multiply by a. We also multiply by a. So we can cancel out a's. So a will cancel with this a. This will cancel this. Also this a will cancel this. So how many a's do we have? We have a 1, 2, 3. So how many a's remaining? We'll have a power 3. Our third case, we have a power 3, but everything is squared. A power 3, but everything is squared. A power 3, but everything. So you are given a power 3 squared. How do we solve this? This means a power 3 is multiplied by a power 3. And this one also, this alone means a multiplied by a multiplied by a. And this one is a multiplied by a multiplied by a. How many is? 1, 2, 3, 4, 5, 6. So your answer will be a power 6. From the three examples, we can derive the three laws of indices. From the three examples, we can derive the three laws of indices. But remember, this all these what we have done here is possible only if a is common. So a must be common in this case, and a is our base in the three cases that we have discussed. So I've said from the three examples we can derive the three laws of indices, and let us see how we can derive these three laws of indices. From example 1, we add a power 3 multiplied by a power 2, which was the same as a power 3. In fact, our answer was a power 5. How did we get 5? This is the same as 3 plus 2. So this is a power 3 plus 2, which is the same as a power 5. So in simple terms, from this you can look as if you look at the bases, the two bases are the same. They are the same. In other words, they are common. So if the bases are common, if you look at our answer 5 and the powers were 3 and 2, so what we have done here is just adding the indices. So our therefore, if you are given, so therefore if you are given a power m multiplied by a power n, this will give us a power m plus n, and this is our first law of indices. Look at let us look at or derive our second law of indices from example 2. So we have we had a power 6 divided by a power 3, and our answer in this case was a power 3. How did we get this? So our powers were 6 and 3, but we have produced the answer as a power 3. How did you get this power 3? You can look at, if you look at the two numbers, 6 minus 3 will give us 3. Therefore, this is the same as a power 6 minus 3, which will give us a power 3. Therefore, from what we have seen, then a power m divided by a power n, this will give us a power m minus n, and this is our second law of indices. That one is our second law of indices. From the third example, we had a power 3 squared, and here we got our answer as a power 6. How did you get 6? It is 3 multiplied by 2. So a power 3 squared is the same as a power 3 multiplied by 2, which is the same as a power 6. Therefore, our law will state as, if you are given a power m, this is raised to power n, this will be the same as a power m multiplied by n. So this is our the third law of indices, the second law of indices, and in this case we had our first law of indices. So that is how we derive so this is our first law of indices, the second law of indices, and the third law of indices, and that is how we derive the three laws of indices. If I state them, the first law says a power m multiplied by a power n, this is the same as a power m plus n, and this applies if the bases are the same or they are common. The second law states that if we have a power m divided by a power n, this will be the same as a power m minus n. So it's a power m minus n. And the third law of indices states that if you are given a power m, if you are given a power m raised to n, this will give us a power m multiplied by n, and this is the first law of indices, this is the second law of indices, and this is the third law of indices. A point to note: these laws only apply when the base is common. So when I say the base is common, it means that the base is the same. For example, A and A, or 2 and 2. So the first base must be 2 and the second base must be 2 if the bases are 2. So if the first base is 3, then the second base must be 3 if you want to apply the 3 laws of indices. Let us go straight to example. So example 1, if you are given 2 power 5 multiplied by 2 power 3, 2 power 5 multiplied by 2 power 3. So this will be the same as, from the first law of indices, this will be the same as 2 index 5 plus 2. Plus 3, because our second index is 3. So this will be 2 power 8, and that will be your answer. Why is it possible to apply this law? It is because the first base and the second base is common. So the two bases must be the same, all must be common. The second scenario that I want you to look at is here. If you are given 2 power 4 multiplied by 3 power 3, are you able to apply the laws of indices? The answer is no, because the bases are different, so you cannot apply the law of indices. The first base is 2 and the second base is 3. So you can only apply these laws of indices if the bases are the same. Zero index. Zero index. What do we mean by zero index? Zero index, when we talk of zero index, I want you to have this in mind. Anything to power 0 is 1 and can be illustrated using the second law of indices. So if you find any number that is raised to 0, then that number is the same as 1. How do we prove this? Suppose we have a power m divided by a power m, and these are the same numbers. So this is the same as a power m minus m, because this is the second law of indices. When we have division, when the bases are the same and division in between, then we subtract the indices. So we subtract the powers. So m minus m is the same as 0. So this number will be a raised to 0. So that number will be a raised to 0. But we can express this in a different way. If you are given, remember we had a power m divided by a power m. So this can be expressed as a power m over a power m, and a power m cancels here 1, a power m cancels here 1. So the answer would be 1. So since this is the same statement, we can say a power 0, which is this one, will be the same as 1, which is the one that we have gotten from the second statement that we have expressed, a power m divided by a power m. Therefore, if a power 0 is equals to 1, then this is what we call the zero index. This is what we call the 0 index. Therefore, if you are given 10 power 0, then this number is the same as 1. If you are given 100 power 0, it will be the same as 1, because we have said anything less to 0 is equal to 1. 1000 less to 0 is equals to 1. 1 million less to 0 will be equal to 1. Even 25 less to 0 will be equal to 1. In simple terms, any number less to 0, the answer is 1. Let us look at a few examples. So, let us look at a few examples in this A. So, A, if you are given A power 7 multiplied by A power 2, how do we solve this? So, the solution to this will be A power 7. Because the bases are the same, we would apply the first law of indices. And the first law of indices states that A power m multiplied by A power n, this will be the same as A power m plus n. So our answer will be, so A power 7 times A power 2 will be the same as A power 7 plus 2. And your answer will be A. Our answer will be A power 9. Will be, our answer will be A power 9. That is your answer in this case. So the second example, if you have A power 4, 4 power 4 divided by 2 power 2. 4 power 4 divided by 2 power 2. So in this case, you cannot apply any law of indices. Why? It is because the bases are not the same. But we can manage it in a different way. So 4 and 2 are not the same, because we said for us to apply the laws of indices, the bases must be the same. So 4 and 2 are not the same. So, but we can maneuver and get the answer. So this we can do it as 4 times 4 times 4 times 4, because 4 power 4 means 4 multiplied by itself 4 times. We divide by 2 times 2. So 2 will cancel here 1, 2 will cancel here 2 times. So here 1, here 2. So we remain how many 4s? 1, 2, 3. So this is 4 power 3. And that is our answer in this case. So if you realize, we were not able to apply the law of indices because the powers, the bases are not the same. In the third example, we have 3 power 3 raised to 4. So 3 power 3 raised to power 4. In this case, we are going to apply the third law of indices. And the third law of indices states that if you are given A power m raised to n, this will be the same as A power m times n. So in from our example, we'll have 3 power 3 raised to 4 will be the same as 3 power 3 multiplied by 4, and this is the same as 3 power 12. Is the same as 3 power 12. Let us look at example 2. So example 2, if you are given 3 raised to 2x and everything is squared equals to 81. So that is our example. How do you solve this? So if you look at this example, we are going to apply the third law of indices. So this will be the same as 3 raised to 2x times, so it will be 3 raised to 2x times 2. This is the same as, so if you change 81 in index form, it will be the same as 3 power 4. So if you don't know how to change this in power form, you can use a calculator and you can be able to get the power form of 81. So in other words, changing 81 in index form. So 2x times 2 it will be 4x. So this will be 3 raised to 4x, which is the same as 3 power 4. Since the bases are the same, we are going to equate the indices. So all the powers, 4x will be the same as 4. So we divide here by 4. We also divide here by 4. So 4 cancels. Here you remain with x, and 4 here 1, 4 goes here 1. So our answer will be x equals to 1. X will be equal to 1. Example 2, in this area, we'll have 2, this is our part B of our example 2. So part B, we have 2 raised to 3x, 2 raised to 3x. Everything is squared, and this is equated to 4096. So 4096. Remember, we must change this to index form. So from the third law of indices, we will say as this 3x we multiply by 2, and this will be the same as if you change 4096 in index form, will be 2 power 12. So since the base are the same, we will equate the power. So this will be 6x, because 3 times 2 is 6, which is equals to 12. If you divide by 6 here, you divide by 6 here, 6 will cancel with the 6. Here we get x, 6 here 1, 6 here 2. So your answer will be 2. So that is our answer to this question. I want you to pause this video and try to do this exercise and see whether you have understood what we have covered so far. So simplify the following. Number 1, you have 27 raised to a third. B, you have 475 raised to power 0. C, you have 3 raised to power 3 multiplied by 3 raised to power 5 multiplied by 3 raised to negative 2. Then D, you will have 512 everything raised to power a third. Then you multiply this by 2. You divide, not multiply. We divide this by this by 2 power 4. I want you to try those questions and see whether you have understood what we have covered. This marks the end of our lesson today. Remember to subscribe to our YouTube channel so that you can be able to get alerts of more and many lessons that we are going to prepare for you. And remember to invite other members to learn with us. Thank you. We meet in our next lesson.